Hello everyone, my name is Hisham. I'm the owner of Clemson Aeronautics, where we make the riveting and dimpling systems. This video is the recap of all the other videos that I made for the horizontal stabilizer, which we call the summary. There's a lot to talk about building the horizontal stabilizer, and after I finish this video, I would probably watch it and realize that I missed some things. And when I do, I will write them down and make a second video to be after this one to explain the things that I missed on the first video. I would like to mention to everybody before I start that we are having a price increase soon because of the price of steel had went up considerably. The machines that we have built and the tools, the yokes and stuff like that was tools that or steel that we purchased when the price was a little lower than what it is now. So we have parts in stock to make the machines right now, and what we are going to do right now, we're gonna put a $50 discount on our primary machine, the card one, riveting and dimpling system. And so it was today's price was $600, and now it will be $550 till the end of the month, starting tomorrow. And the yokes will be discounted $10, so it will be $100 a yoke. I mean, this is cheaper than anywhere else in the world, literally. Also, a reminder, the finder's fee response form, if you fill that up and we receive a check from Vans Aircraft, you'll get a $100 credit towards the purchase of anything, so that our primary machine that you will buy in the next few days till the end of the month for $550, you can get a $100 credit on that too. So you wind up buying a $600 system for $450. That's a good deal. Please don't miss it, because the prices are going up. There is no two ways about it. I cannot control that. It's the price of steel. Most of the things that I need to talk about, I need to point out in the book. But before I get to the book to start explaining the things that you need to watch out for on the horizontal stabilizer, there is a few main things that I would like to point out. The rear spar have a notch in it. If you can imagine, the horizontal stabilizer that's on the bottom, okay? And there is a group of 9 rivets on each side here. Those also on the bottom. That is the orientation of these two parts, the rear spar and the front spar. Keep that in mind the entire time while you are building the horizontal stabilizer for orientation. I will go into details in the book with you guys, so you can have a clear picture what I'm talking about while I'm explaining it. The other thing that I wanted to talk about and let you see it on the horizontal stabilizer itself is these brackets, or the cradle. I made the mistake of making them too long. Even the ones on the end, like this one right here, goes all the way up. That was not a good idea at all. So you need it till about right here or so. You don't need to go any higher than that, because you're pretty much trying to get the airfoil of the skin in the shape of your ribs to do the nose ribs. After that, everything falls into place with ease. It's not a big problem. The downside of having it too long and exact shape of the ribs is because it gets narrower as you get to the aft part of it, and now you'll be having difficulty trying to put it in and out of the cradle. So if you have it till here, the thickest part of the horizontal stabilizer, you won't have this problem like I did. Now let's talk about parts orientation. As I mentioned before, this is the rear spar. And the way it's in the book, it's shown kind of correctly as you're looking from the back of the airplane forward, and this notch is on the bottom. There is 4 holes here that don't actually exist, and these 4 holes here, that you're gonna have to drill these, or what we call match drilling. And once they are drilled, they are kind of like a V shape. So the orientation of this part, you can easily flip it over 360 degree in the horizontal axis, or you can flip it upside down without knowing, and you start riveting. So my advice on that is, when you cleco those in place together, the rear spar and the doubler, you might want to mark it forward and aft, and also top and bottom. Right top on both edges here. You cannot mistake the spar itself, but you can mistake the doubler. The other thing here, when you put the hinges to final drill them here, what I did is I marked them before I put them in there with the clecos. 1, 2, 3, 4, 5, 6, 7, 8. Then I final drilled them. So when I got them off, I knew where to put them back in, each one. So they are marked good with a good Sharpie. Now on page 3, when we talk about the flange bearing, you also need to mark those, because you're going to be doing some final drilling on those. And when you mark them, you have to mark the flanges orientation, and you have to mark the flange of the bearing itself, because you could have the orientation here correct, and this could be flipped inside. So you need to mark this good before you start assembly of the flange bearing. Also in the procedure, it mentions here that you can take those flanges and bolt them down to something after you cleco the assembly. When you get ready to rivet them together, you bolt them down to a flat piece of plywood or a 2x4 or something like that before you rivet them together. That way the flanges itself is directly perpendicular before you start riveting them. You will have a good result from that. Another issue with the flange bearing, when you try to bolt it to the spar, it tells you to go to section 5.2, and there is a chart in there. This is very, very little torque, so be careful. 28 inch-pound, not foot-pound. If you put 28 foot-pound, that is way too much. So you need a torque wrench that goes really way down there to 28 inch-pounds. Now we get into the spar caps, and stringers. You're gonna do this cut. There's nothing to it. It's very simple. The issue with those that you have to be careful with is match drilling. When you come to here on page 4, and you're gonna start doing some match drilling of the caps, and well, the stringers, I don't think you need to do match drilling on this stringers, but you're gonna do it on the caps. You have to make yourself a procedure, because it is very critical. Why is it critical? It's because the caps doesn't have any holes in it whatsoever, and the holes that you're gonna create in it is you're trying to line them up with the holes on the front spar. So we're gonna do, let's say, the holes on top or on the flange. So you're gonna have to hold them with a special kind of cleco, which is a cleco clamp. Try and get as many as you can, and you hold them in place pretty good. Then you start drilling your first hole and start installing clecos as you go, so it doesn't move. After you finish one side, you have to take it apart, deburr it, and put them back together to match drill the other holes. So from the side, these are number 40 holes, and that's on the flange, in other words. But what's on the body of the spar itself is a number 30. So what happened is that after you finish the number 40 holes and you put it back in to match drill the number 30 holes, when you put it back in, it might not get exactly lined up with the holes, and I will tell you why. Folks, this is the cleco, and what you do, you're pushing on it, and then you're putting it in the hole, then you let go to grab. You have to understand that this area here of the stem is much narrower than the hole itself. So if you put the cap back in and install one of those clecos, the holes might not be lined up perfect. And when you cleco it, it will hold it in that position, where all the holes that you have just finished match drilling are off by, let's say, a couple of thousand. But they are placed now and they are secure in place, and you're going to start drilling the number 30 holes. So now the number 30 holes will be lined up with each other, but the number 40 holes are off by a couple of thousand. Then you will remove it and you deburr it and all that stuff. When you try to assemble the horizontal stabilizer together, you either gonna have the number 30 holes lined up together perfectly and the number 40 are off by 2,000s, or you're gonna have the number 40 hole lined up perfectly and the number 30 holes are off by 2,000s. You guys see my point? So what you need to do really is something very simple. Let's assume that you are going to do the number 30 holes first, and the same would work out the other way around too. So you match drilled all the number 30 holes on one of the caps, and then you took it out and you deburred it, and you want to put it back in so you can match drill the number 40 holes. When you put it back in, before you cleco it, I guess would be the other cleco, the copper color cleco, take a couple of number 30 drill bits and use the back end of the drill in 2 of the holes to make sure that they are lined up perfectly before you start cleaning, because this is very close. This could be just 1/1000th under the size of this, or even 0.5 less than the point of the drill itself. So if you use 2 of them and you put them in the holes of the number 30 holes that you just put in, it lines up the holes perfectly. Then you start cleaning it. Once you click it, it holds it in place and everything is good. Also use the cleco clamps to hold them in place while you are match drilling the other set of holes, whether it's the number 30 or number 40. When you do that, you guarantee that the new holes that you're drilling is going to be lined up perfect, while the others are lined up perfect because you match them with a couple of drills in there. Again, this is the front spar, and this is the 9 holes that we're talking about right here. These are on the bottom, so you are going to also do some match drilling for bigger holes. When it comes to the spar caps and the holes that you're going to have a universal rivet with, in other words, you're not going to be dimpling that. You can use the drill itself, the size, like a number 30 or a number 40 drill, to do the match drilling or final drilling. Because you're not dimpling it, the hole is not going to get bigger. So the holes, the bigger holes, you're going to find a few holes that are much bigger. It's like here's final drill number 12. There's others that's final drill 1/4 of an inch. Just as a suggestion, I think when you're talking about 1/4 inch, you're talking about mounting the horizontal stabilizer to the airframe of the airplane. It would be a good idea, and that's what I done personally, is drilled it with a size smaller than a 1/4 of an inch, just a little bit less than 1/4 of an inch, then use the reamer to get it to the 1/4 of an inch to get a perfect round hole. Going back to the cradle, Van is correct. You don't want the cradle to go all the way up here. I made the mistake. I thought, okay, I'll do it better. I'll go up all the way here. No, that was not good, because that area is bigger than this area, and if the cradle goes in like that, it will be difficult to get it in and out of the cradle. On this page, it talks about the 10 degrees here and 12.5 here. Well, actually, what you're gonna do, you're gonna bend this one 10 degrees, and then you're gonna actually bend it 12.5 degrees. Then when you bend this 2.5 degrees up from this area here, it becomes 10 degrees to match this one. Don't really wear yourself out trying to get the 10-degree perfect. Try and draw it on a piece of paper and line it up as much as you can. It will flex a little bit while you're doing the assembly. I don't think you'll have any problems with that. Again, orientation. Those holes are not going to be dimpled, and those here. But these are on the, like half of them is on the bottom of the horizontal stabilizer, and the other half is on the top. But these here are only on the top. During the assembly, you need to be careful with the flanges of the ribs to make sure that they are laying flush on top of where you are going to riveted. You can tell here. So, and if it is not flush, you will have a hard time riveting it, and you might have to resort to pushing on it or something while you're riveting it to make sure it lays down flat before you start riveting. Please excuse me, I am not very organized. It's April 21st today, and it is so cold. I'm in South Carolina. It is so cold, and the shop is really cold. And but anyhow, so if I am sorry I'm taking so long to mention everything, but I promise you this will be well worth it. One of the things about orientation of the parts, you will mark them with something, then you will prime it, and you can lose your mark. So how do I prime my parts? What I do is, and I'm trying to find a part here that would be a perfect example for this, so I'll just grab. If I was to prime this part, let's say it's ready to prime, and it have orientation, top, bottom, or whatever on it, I write the orientation in several spots, and I split usually half. I write it here at least once, and here at least once, and in the back, and so forth. And what I do, I took a 2x4 and put a bunch of nails in it, and by the way, you need to wear gloves. Once you scuff this up, you need to have gloves on, and start wiping them with rubbing alcohol or acetone or whatever you're going to use to degrease it with before you prime it. And then you have the gloves on, and you're holding this part. What I used to do is I would hold the part like from one end, and I would spray it. Then I would go and hang it on one of the nails on the 2x4. So this part here is not primed, but this part is primed. I still have the markings here. I hang it. When it dries, and I'm getting ready to prime the other half, I take my marker. Now this is marked here. I mark on the part that is primed. Then I would hold it from this side and spray the primer on the other side. So I have the marking on this, and I use this as a system with most of my priming that I've done, just so I don't lose orientation of my parts. With the horizontal stabilizer, I was able to match drill, final drill, dimple, everything before and primed it before I started assembly. So all the parts was separated, have not been riveted together, and I primed everything. Then I started the assembly. I've heard a lot of questions on the internet, people and doing this mistake. I've seen it many times on the internet, where the spars, you're countersinking the spars because this is where the skin is gonna be on. So I see a lot of people, they are match drilling and all that stuff and not countersinking. Then they prime their part. Then they countersink. So let me say that one more time if I confused you. They do all the match drilling if they needed to, because this part, actually, you don't need to do any match drilling on the holes itself with the skin, because the skin is drilled to size. So what happened is that they prime their spar, then they countersinking. Well, that part that is countersunk now doesn't have any primer on it. I think after you do the caps, match drill the caps and so forth, you can countersink your spars before you prime. Then you prime them. Now you have primer all over your parts. Then you can start assembling. Okay, now the front spar, the countersunk holes on the flanges for a number 3 rivet. There is in the middle of the spar, there is 9 holes that is countersunk where the rivet is flush. That's easy. Those 9 holes, you need to just have them flush. So you adjust your countersink tool, that the stop, micro stop, to give you a flush rivet. How about the rest where the skin is gonna lay? And really the manual does talk about it. If you dig through the manual to find it, it's not in this chapter, it's back in chapter 5. So what do we do? Because the dimpled skin, you have, the skin is so thick, and when you make a dimple, if you want the skin itself to be laying on the flange of the spar, you have to go so deep with the countersink to make that dimple sink in all the way. They don't want you to do that because it's a long story. At the end, what do we do? What we do is, you had it set to give you a flush rivet for those 9 holes in the bottom. Then you need to go 7 thousandths deeper. So the dimple of the skin would sink in there a little bit, but it's not gonna sink in there all the way. But it will be good contact when you rivet it. So how do we do that? On the micro stop, the gears on it that you adjust the depth with, each one tooth is 1/1000th. So when you adjust your the micro stop to do the flush rivet, all you have to do is make it go deeper 7 clicks, 7 tooth. Then you just countersink all the holes on the flanges of the spars, and it will come out great. My horizontal servo, I have no problem whatsoever, no issues whatsoever. Everything is working just fine. There has been a lot of instances, because I primed all the parts, it gives the parts a little bit of thickness. So a lot of the rivets did not work as far as lengthwise. So I had to go step up on the rivet. So you have to do that for yourself. When you see, don't use a short rivet. It's not going to give you a good chop head. It's going to be very little in thickness or in diameter, one of the two if it's short. So might as well go up a size on the rivets. Again, the bigger holes, like the 1/4 inch holes, are made to bolt actually your control surface to the fuselage of the airplane. Me personally, I would feel much better if I reamed those holes. So under size on the drill, then use a reamer to give you a good, nice, clean hole that will last for a long, long time. You've probably seen me talk about how when you dimple the skin, the hole gets bigger. That's why I use a smaller reamer or something in previous videos. But in this case, when we're talking about the spar, if you use the number 30 or a number 40 drill, you're not dimpling that, you're countersinking, so the hole never gets bigger. So I'm sorry repeating myself again. You can go straight to that size drill, number 30 or number 40, and it will be fine. This is all I can remember for things to watch for. I really think it's a good idea, and that's exactly what I did. Is I went through the whole chapter, reading the whole thing to see what I'm getting into. Watched a few videos of other guys doing a great job, other guys messing up, and good thoughts about how you're gonna proceed with the horizontal stabilizer will go a long way for you. It will help you quite a bit. It will organize your thinking and will shorten the time that it would take to build the horizontal stabilizer. Riveting. Make a riveting day or two plans with a friend of yours that is good at riveting, somebody that had done that before, and to help you with the rivet gun or the bucking bar. You guys need to stick with that and make a team to rivet this horizontal stabilizer. You'll be well off. Use tape on the outside, and when you put a tape on the rivet, you can't see where the rivet is. So it's a good idea when you put a tape over the rivet to hold it in place while you're riveting it. Take your Sharpie and make a circle on the outside where the rivet is, so when you're pointing the gun, you have it in the middle of the gun. Again, a reminder, we have a sale that's going to only last till the end of the month. Please take advantage of that if you are doing the planning. If you are interested in the front end only of the machine, it is a little bit difficult to do that. It will save money, but I have a plan for those of you that are interested in just the front end. It's not going to be just the front end. And let me explain briefly what happens here. When you take that front end, there is a main plate that holds everything together on our machine. This plate right here. When you weld that to the frame, the heat from the weld actually warps the material. It warps it ever so slightly. You can't see it with the naked eye actually, but it is not a flat surface anymore. So what we do, actually, we weld it to the frame, and then we take the whole thing and put it inside the machine. The top, just the top part here. We take that, we weld the face plate to it. Then after we weld it, we take it and put it back on our machining center. And we do a lot of calibration to make sure it's positioned correctly and the machine knows where it is correctly. Then we actually mill it flat again. So after we're done with that, now we are sure we have a nice flat surface to work with, so the shaft goes up and down perfect, perpendicular on where it's supposed to go. So our plans are for those folks that wants to or thought of buying just the front end and building their own frame. It's not going to work with this machine because you need perfection here to get all these parts to work together. There can't be any warpage at all. So what we're planning on doing is selling just the top half, that top half here, welded up and ready to go, just this part here. Now this part here, because this is 1/4 inch material, it is very thick and it is very heavy. After we put all our parts in place, it weighs 40 pounds. That's a far cry from like 75 pounds if you buy the whole machine. So the shipping is not going to be as bad as shipping the whole thing. It will be much less. And I managed to do some things and get some discounts and stuff like that for shipping also, that is going to take place very soon, and with UPS. So shipping just the top part by itself will work and will save you some money, and the price of it also is not going to be painted, of course, because you're going to have to build the rest of the frame yourself and weld it up. So it will work out a lot cheaper. So here is a good idea for those of you who are waiting for their empennage kit to come in, and they know it will be 2 or 3 months down the road before it will show up. Now would be a good time to call me, and I will plan it with you where I can ship this to you, and you will receive it, of course, well before your empennage kit comes in. And what you are going to do, you're going to build the rest of the frame and weld it up and everything. Make it as strong as possible back here so you can rivet with it and paint it and all that stuff. You're going to save a lot of money doing that, and it gives you a chance to build a cart for it. A cart so your machine will be moving while the table is steady, so you can work with that. I think that is a good plan. I'm working on it, and for those of you who are interested in that, and also bear in mind, if you do send that form, you will get $100 discount on that too, so you'll be doing a lot of savings. Especially also on the yokes. The yokes are very beefy, very strong, very nice. And a new design that would help get into narrow spots and stuff like that, and also deep with our 4-inch yoke. 4-inch yoke is terrific. My advice: buy one. It will help you and will save you a lot of headaches. Sorry it took so long. Please like our videos and please subscribe to the channel. It helped me a lot. I'm doing all of this for you guys and going through the agony of building and making the videos at the same time. But anyhow, thank you very much for watching. I will see you next time.